Welcome to our webinar for releasing version 4 of MultiRate. I'm aware that we are competing with a celestial event, so thank you very much for spending some time with us. It's definitely a less rare event and probably less likely to cause damage to your retinas. So thank you. Just a note here at the start, we are concentrating in this webinar on looking at the new functionality in version 4 of the software. We do have a mix of people attending this webinar, including current users, but also others that are interested in seeing what we're doing with this. If you have questions that are not related to the new functionality, that are more general about MultiRate, let's handle those offline. Send me an email or give me a call. We can talk more about those sorts of things, and we'll concentrate more here on the new functionality, just so that the current users can see all that. All right. With that, let's just jump in here. On your screens, we've got the normal MultiRate view. We're going to start looking at something that's new here, where we're able to select different fields with a little bit more of a guided approach, where MultiRate will actually make some conclusions about what the fields are when you're selecting them. So first of all, this data is just some data on automobile auctions and whether or not those vehicles are getting returned after the auction. The field of interest here is this is bad buy. This is saying 12% of the time we've got a return, and the rest of the time we do not. We're going to select that as being our target field. We know that, but let's say that we don't know much else about what's on this table in terms of what they are. Now we can go through and inspect each one of these to see what sort of values they have and all of that, but we may want to have the software make help us with that a little bit. So for example, for purchase date, if I say I want to use that as a field, it's going to guess that we want that to be a grouped field. Because this purchase date takes a wide variety of values. It's assuming that we're not going to just want those to be categorical values, each with their own factor. It's also assuming that we want to use variable gradient smoothing for that, since it is a grouped field. If data can be binned in the first place, that means that neighboring bins very well could be related to each other. But let's do something here with select all. So you notice it selected that for us. If we hit select all now, it's going to do that for each one of these fields. So you notice, for example, for this reference ID number, it selected that as a detail key. The reason why it did that is that it noticed that every value of that is unique across the table, and so it guessed that we want to use that as a detail key. You can always change it, but it's kind of a nice feature to be able to go through and have those things determined for you. Some of these, for example, vehicle year, vehicle age, I might want to make those variable gradient, even though they're not grouped, just to say I expect neighboring values to be related to each other. But other things, make and model, it's assuming correctly that those aren't things that we would group together into bins. But down here, odometer reading, it is assuming that that's grouped, etc. Go down a little further, we'll see variety here. Zip code, it identified that this data is organized as a 5-digit zip code and selected that as well. We might want to make a choice here, though, to select something different. There's a different choice here now, actually, for smoothing that wasn't there in the past. This is to have layered, which is very similar in nature to variable gradient. Same concept that we are going to smooth data across a number of different radiuses. But whereas variable gradient will then select from among those different radiuses for each bin, or in this case each zip code, layered actually maintains each one of those different radii as a distinct layer that can be turned on or off, which gives the user a bit more control over that. although that does come with some complexity as well. So like a lot of things, that is a trade-off. But let's put that in there as layered. We're going to click OK here, and we'll let it select that. Another thing that's new here is that down below we've got this shrink for zeros. What that is saying is, because remember, if we looked at that target field, 12% of the time it's a value of 1, the rest of the time it's 0. In a lot of cases that we look at, particularly in insurance, we've got things like frequency, where you might have for smaller accounts, let's say it's personal lines, you may have a very small fraction of the policies in any given year that actually have losses associated with them. And so this is something to make analysis even faster. The ability to shrink out zeros. So what we're relying on there is the idea that, or I should say the implicit assumption, which may or may not be true, but the assumption that as you have a higher modeled result, so your factors are combining together to give you a higher modeled result, that you at the same time with that would have a lower probability of having a 0. If that's true, if that relationship holds, then if we randomly remove some number of those 0 records, we'll end up with something that has the same ordering in terms of our model as when we had those full zeros in there. It would be a monotonic transform on that data, and all we really would have to worry about is the rank within our model. And so then what happens is it ends up using curve modification on the back end. Basically, it's building a model around that shrunk data and then using curve modification on the unshrunk data. And what that does is gives you some computational efficiency, basically, by doing that. To illustrate that a bit more, I'm going to go to another analysis where that's been done. So this is actually a frequency model. And we have selected there. This only shows up, by the way, this shrink zeros in cases where you have at least 3 times as many zeros as non-zeros in your target field, and also where the average value across that target variable is less than 0.5. So things that you might think of as being binomial or Poisson or like those would be good candidates here, and this won't even show up in other cases. So in this one we have run it. This is a frequency model, so we have a relatively small number. When we look at some of these fields, this is a small fraction, actually. I think like 1/10 of the actual exposures. We have all of the values that all of the target, all of the records, I should say, that have target not 0 are represented, but a random sampling only of the exposures. So our exposure here is about 1/10. We have all of the target. Where you can see this most clearly as far as how this is being used, if we look at the view model fit graphs and we look at the decile chart. I'm going to start with the training data here, actually. So from left to right, we've got our modeled result. You can see the red dots here for observed observations. This is on the training data. You can see there's a lot of zeros still here, even though we've trimmed a large number of them out. And you can see our blue modeled, just factor relationship is fitting well to the averages within the different deciles across our different factors. But our curve modification, after applying curve modification, which is looking at the full data on the training data, is considerably lower because we have a lower base probability than what's being seen on this shrunk down data set. If we switch over to the test data and look at the red dots, or red circles rather, you can see that now the red circles actually fall along along the green line, showing that when we apply that model where we basically are just looking at rank order and then rescaling it at each one of the different percentile points to the training data, how well we do on the test data. So that's a new feature there. And now I'm going to show you a little bit of some of the data visualization that we've improved in here. We're going to stay with this written premium, but we're going to look graphically. So one of the things that you'll notice is that the size of the dots now varies. In the past, that was set to be just a constant area for each one of those dots. Now it's actually proportional to the amount of exposure, which takes a little getting used to, but once you get used to, you'll really like it, that you can see quickly, all right, I've got a lot of data in these two bins, for example. The other thing that you'll note is that the null bin is not shown here. The reason is that we've got no exposure in that particular bin, so there's no reason to take up landscape in this particular graph. Next, I'm going to look at, also note that we still have a line here for the modeled result. This line is being shown because this is a grouped and smoothed field. The fact that it's saying that there is a relationship that exists between these bins. But as a contrast, if I go to deductible, in this case, these are being actually treated as distinct bins with no smoothing. And so in this case, instead of a line connecting them, we now have these line segments. So just a quick view to say, okay, am I smoothing or not, on this data. And then here you can also see the size of the dots that are very different. In the past, you might look at some of the data and say, oh, I have a big factor here, or but it might be on a relatively small piece where you just might not care that much about it. But here it kind of focuses on, it's really kind of 1,000 versus 2,500 differential that we need to pay attention to. Okay, and then the last one here is zip code. Here I'm going to show. So this is an example with that layered idea. So I've here selected a particular radius. So what this is doing is it's actually looking at each one of these different radiuses, and these are in kilometers. So 0 means that geographical unit stands on its own, so the zip code just by itself with no smoothing. That's a specific layer. 5 kilometers, 10, etc. You notice it says layer excluded here. This would have been radius equals 300, but this one has been deleted from the analysis in the process of refining it, and then we've got a combined result that pulls it all together. One thing to note here, okay, so all of these different layers are being treated as distinct variables in the parameterization. So just like everything else in multi-rate, they're being looked at after adjusting for everything else. So that includes the other layers. So this particular layer is already adjusting for layer 1, 2, 4, 5, 0 as shown up here. But the nice thing about this is it gives the user a fair amount of control then to say, I want to only have the smoothing operate over a certain type of radius. I don't necessarily want to have that variable gradient concept. I still use variable gradient for most things, but it's nice to have this flexibility to be able to look at things this way. To be able to eliminate it, you can't do it actually from here. Well, actually you could select a radius back in here of -1. That's how you'd let it know that layer is being excluded. But I typically will just go here and say trim characteristics and get rid of it that way. To show you another example, this is back to that auto leasing or auto auction data and whether or not the vehicles are returned. So this is actually fairly thin data. There's not a huge number of zip codes actually here. So when I look at radius equals 0, so not smoothed, you might be able to pick out some of these little reds and greens that are picking out here. It's just a number of zip codes here. This is another feature actually of the software that's new for version 4, is that variable gradient smoothing existed before, but it was still only looking at those zip codes that were in the training data. Well, you could have something in your test data that's right next to it, and you should be able to draw the same sort of conclusions using variable gradient smoothing there as you were for the thing that was represented. And so what we're actually doing here is anything that's within the convex area described by those boundary points, the points that you actually have observed, will actually get a score here. We'll actually get factors. So this one is kind of boring because you just see basically the normalizing constant for the vast majority of the zip codes. But as we start going up in the higher radiuses, you can see 5 kilometers for a radius, 10 kilometers, 20 kilometers. Each one of these as a distinct layer that get combined together. Once we get to 300 kilometers, it's very broad, and then we have a combined that's here. Now, each one of these, in terms of their colors, is rescaled to their particular layer. It could be that this 300-kilometer map has very thin factors. This might be a factor of 1.01, and this might be a factor of 0.99. You can't necessarily tell here because I didn't include the scale. But the combined factor is basically just all of those different radiuses combined. So that's layered losses there. Okay, now I'm going to show you one of the most exciting features, I think, of the software, and that's to look at the improvement process. As all of you know that are users, one of the big things that takes human time here, as opposed to CPU, is the process of refining your models. And going through and saying, okay, I can tell that these particular variables are performing poorer than others. Maybe they've beaten random characteristics, but I still want to see what the model looks like without them. Or this particular variable has a high level of correlation to another one. Can I get rid of that and basically have the same model or maybe better? What should I do with credibility? Making changes there and seeing what sort of impact it has. That process now is guided significantly by using version 4, and in particular this little light bulb up here is new. It says improvement mode, and there's different modes to it. So we can say none, which is basically the same as before. Suggest improvements, which is to after each run of the analysis, it will suggest improvements to you. Or auto-improve, where I actually go through that process repetitively for you. So we're going to show you each one of those. But first of all, we're going to select some data. So this is some data that one of our interns had identified. That's kind of fun. It's nice for webinar purposes because it's very fast running, especially when you're running a bunch of different versions of this particular model. And this is looking at quality of red wine. Now, I haven't looked at this much to know exactly what they're talking about. But the field of interest here is just called quality. If I highlight that, we can see that it takes different values. This is ranging from 3 to 8, 8 being higher quality, and we've got different percentages in there. We're going to use the select all feature with the guiding that it's going to do us, and we see that the detail key here has been selected as our detail key. Kind of boring in terms of the select because they're all grouped. These are all continuous fields. But imagine the case where you've got 100 different fields here, and you're trying to make some sense out of it. This can be this together, especially combined with the calculate R squared, can be very helpful for you when you're first getting your data in. So let's select that. Oops, I did not select that as my target field. Oh, let's go back here. Let's put that as our target. And let it pick a credibility level. It's picking 4. So these are individual records. It's just saying 4 records will get 50% credibility. We're just going to go ahead and run that. A very fast model. We can talk a little bit about some of the results that we're seeing here. As we get more alcohol in the wine, it's getting a higher score. Oh, it's already done. Okay. So we're going to go ahead and save that. And we're going to save that there. Okay, so that just ran as normal with none. Now I could rerun it here with suggest improvements, but instead I'll just run it this. I'll just go like I'm going to run again here, and that would be the same as if we had suggest improvements from the start. It's going to evaluate. Okay, so it's evaluated, and it's actually picked up my checking there, a number of different things that it thinks would be worthwhile changes. So, for example, it looked at a lot of these fields and it said, the linearity of the dots, and again, all this is on the training data, is fairly strong. Let's try making that particular field linear. Credibility standard, you'll see it changing lower and higher. When it's aiming lower, it's typically because we want to give more credibility to it because we're seeing things on the edges that indicate that we could go further along the relationships that we're seeing. There's a case here where it's suggesting changing the bin breakpoints. It's looking at the slope along that curve and seeing that in some cases it's very flat. Those can be combined together. In other cases, it's more steep. Let's break those bins apart because maybe there's more differentiation that we can provide that way. This one didn't find any interaction effects. We will show you an example of ones where they are being found. But that's another thing that's being done. And this has been one of the things as I've been using the software that has really been interesting, is that we always talk about you got to look for interaction effects that can be really important, but sometimes you just don't bother to do it. And it's really nice having something where it's scanning them all for you, suggesting, hey, you really should add an interaction effect here. That would add a new column to your data. And this is one where it's saying to drop a particular characteristic. Now it's looking at a number of things there. Some of these might have been dropped except for the fact that we're trying linear, but it's looking for things that are at the low end of predictive power and also have more in the way of parameters. So it's trying to make the model simpler, essentially. And it's also then looking at places where there might be a strong overlap between different factors, or different characteristics, I should say. Now you can turn these on or off as far as whether or not you want to include them. I'm just going to go ahead and say change and run. All right, now one of the things you'll notice is that this red wine quality 2, it automatically incremented this for us. If we didn't have the 1 there, it would give us a 1. If you did have a 1, it's going to go to 2, etc. Click that. All right, so it's already done with that next one. We'll save that. And it's telling us then, all right, between 1 and 2, the 2 that we've run so far, red wine quality 2 has the best fit and also has the simplest within tolerance. So basically this is saying if you're going to choose between those 2 at this point, you probably would choose 2. And notice that information is also showing up down here in the status bar. I click OK there. All right, it's already making our suggestions for our next version of the model. It's suggesting raising that credibility standard even further. It's suggesting changing a couple more of them to linear. It's suggesting dropping fixed acidity. It's changing bin points for breakpoints for the volatile acidity. We'll click change and run there. Okay, so we can keep going with that, having it suggest them, or I can just have this auto improve, and it's actually already done. That's fine. We're just going to let it go through its steps here. We can also say delete. Okay, change and run. All right, delete extraneous analyses at the end. What that'll say is, okay, first of all, we're going to go through automatically. We're going to check for interaction effects. The reason why that's included as a choice is because that does potentially add model complexity, and maybe you just don't simply want to deal with those interaction effects, and so you can decide not to include them. But the delete is kind of nice. As it keeps adding new models here, you can end up with 20 or 30 different models potentially. It goes back then at the tail end, if you've got that checked, to say we're going to keep the first one, we're going to keep whichever one is the best fit, and we're going to keep whichever one is the simplest within tolerance. And in some cases, those can overlap. So you can see as we go through this process, it's continuing to find ones that are at least simple within tolerance. Of that best fit. So far it hasn't found one that's better than 2 in terms of the fit, but it is finding ones that are simple and statistically just as good. And so we'll just let that go. It actually won't take too much longer for that to run. Just a little bit more on the process that it goes through. So you might notice on some of these where it may not be one that's an improvement, but it may still kind of go down that same road. So because it's changing the credibility potentially, and that can be a fairly strong dial, at the same time, it's already done here, at the same time as it's also changing other things like removing different variables or changing the breakpoints, making linear, etc. One of the things it'll do is if it doesn't make it better, if it doesn't make it a better fit or simpler within tolerance, then it'll say, well, let's at least let's keep all those other changes, but let's change that credibility standard back. And if after that that's still not an improvement, then it goes back 2 models ago, and it says, okay, let's go back to that point. Maybe let's not make as dramatic changes. You notice it starts with a whole bunch of changes. After a while, it gets to a point where it's like, no, let's stick to kind of one at a time, that sort of view. So if you see, down here that, or actually just watching this, that you've got, oh, it's model 7. Oh, now it's back to model 5. Oh, now it's back up to 7. Now it's back to model 5. That's what's going on. But when we got all done here, we're seeing that it comes down to a few variables here. We've got how much alcohol apparently is our #1 variable for this quality assessment that was made. Sulfates, I guess they do some good in the wine in terms of the quality, chlorides, etc. So here you see again the different dots being different sizes based on what we have there. Okay, I do want to look at the fit deciles here just to show you what our final model ended up being. So we've got what I think it was 5, 6, and 7 were the main ones with a lot of exposure. I guess we can see 4 down here and 8 up there. And you can kind of see how well the model does compared to what we're looking at. So remember now, we set it to deleted, so it actually, this red wine quality 9 started with red wine quality 8, but that one now has been deleted. And we can go in here and compare the ones that remain. All right, and we can see we started with 1, made some changes to get to 2, which was our best fit, but then almost as good and within statistical tolerance of it is this red wine quality 9, and so you can see what the differences are there. Now, yeah, between this one and the last one, they were very, very similar. The comparisons that are being made between them, that is changed a little bit as well. In the past, what we were doing was a Kolmogorov Smirnoff test on the errors. But now what's being done is we're looking at a bootstrap on the test data. You could have situations where, let's say that you had a lot of data, and very significant number of records. You could have errors that were errors, meaning the difference between the modeled value and the actual value on the test data, that showed statistically significant differences between 2 different models, but that had very, very similar fit statistics. And so you might miss something that's very close, just kind of an alternative, a very alternative view for looking at that data that's statistically different in terms of that error distribution, but not statistically different in terms of those fit statistics. That the fit statistics weren't actually were within each other's ranges as far as measuring them. So what we're doing now is we're actually bootstrapping on that test data, on that auto-sample data. We're creating 20 alternative bootstrap samples of that test data and comparing what do you get for a fit statistic along each one of those 20 for one model versus another one, and doing a Kolmogorov-Smirnoff test on those. And so that's a much more improved method of identifying, other models that still could give you a very strong model while still being simpler. Which is definitely a strong goal here. And in some cases, you may actually end up more likely to capture a better fit because you're allowed to go down a different road that otherwise you might have seen for something with a very large sample size, where you don't get much beyond frequency 1, frequency 2, for example, something like that. With any change that you make is being seen as statistically different. This tends to allow a little bit more in terms of alternative parameterizations and models. Okay, so that's the improvement mode. Next, I'm going to show a little bit on the interaction tool, because we've made a little bit of a change there. So for those of you who've used this before, we're going to open up the interactions. This is actually a National Practitioner Data Bank, so medical professional business, and we're looking at a different view than what we've seen before. In the past, we would have seen this view, where we're looking at this interaction statistic that we calculate between different variables. And when you've got a lot of different variables, you find yourself kind of hunting around for, well, which one's the biggest one? Now we just sort them so that you can see that list view. So in this particular case, we've got licensed state together with this payer relationship status. And we've got a high score there. At that point, you can still double click to see the details behind it, things like that. But that's part of the improvement process, is that you can have MultiRate go through that, add interaction effects, and then I've got one where that's actually been run here. And so here you can actually see the result of that, that next round of the MultiRate analysis, and from left to right. Now back to the data visualization here a little bit. So this is Louisiana with status P and Illinois with status S. That in addition to whatever else we might be finding for those variables on their own, we're finding this interaction effect. So again, it's very helpful to be able to see the size of the dots to know how much data is actually there. But a couple of other things to note here. Note that this is one of the examples where we've got more than 20 factors, and so we're only selecting the 20 most significant in terms of amount of exposure and how far the factor is from 1. But we're sorting them differently now. In the past, we had a line, that connected these dots, even though they aren't really connected, and we were sorting from lowest significance to highest significance. Well, all 20 of these, the fact that they're on this at all, is because they are higher significance than the other ones. And we might have a whole. Let's see how many we've got here. So we've got a lot of different factors here. We care about places where there's a lot of exposure and a factor that's different from 1. Because we can see the size of them, there's no need necessarily to sort in that order of significance anymore. So instead, what we're doing is actually showing from lowest to highest, which just makes it easier. You can focus on what are the things at this end, what are the things at this end, what are maybe the big things that you still, they've got a lot in them, so you care about them. So that's just a little different on the data visualization as well. But you can always go back to everything back here. Okay, so I had hoped to go through pretty quickly on all the new functionality, and we've basically gotten through what I wanted to show you. So I don't know if there's any questions that we have. If so, feel free to put them out there. While people are thinking of questions possibly or running for the doors to see the eclipse, just want to reiterate that if any of you, users or not, have any questions on anything that you've seen here, feel free to give me an email or a phone call, and we can set up a time to talk through any of this in more detail. Okay. Not seeing any questions coming up, so I guess I will let you out to burn your retinas to your heart's content if you're not covered with clouds right now. And thank you very much for attending the webinar, and we hope you like the new version of the software.